David Smith here with one more Flipped Classroom math video. Before you start, remember you can always speed up or slow down the playback if that suits you. Second, remember you can turn on the captions and see my words go by on the bottom of the screen. Third, remember to pause that video anytime you need to catch up with your notes or just think about what we're doing. Let's go over chapter 4. So first, let's just talk about the topics. No examples here, but you might make notes because this will be a nice, concise list of everything that we've done so far in chapter 4. So, big formula section. We had a bunch of them. So first off, we have our midpoint formula, like that guy there. We have our gradient formula. That's for finding slope. We could say equals little m, which usually stands for slope. Sometimes I'll do MP for midpoint, okay? And then we had 3 different formulas for lines. We had our good old friend slope-intercept, y equals mx plus b, where m is the slope and b is the y-intercept, where the equation cuts the y-axis. And then we have this point-slope form. This is really good if you have the slope of a line and one of the points that's on it. You can just plug in and turn that into an equation for that line. This is y minus y1 from that point equals m, there's our slope, times x minus x1 from that point. And so that'll give us a line equation if we have a point and a slope. And then lastly, we have this sort of general or standard form, which is a little bit generic, a little less helpful, but we will be converting in and out of that from time to time. And that's ax plus by plus c equals 0, where a, b, and c are elements of the integers. So there's no decimals or fractions. They're solid integers like -10, +30, 2, 1,000. Those are all integers. Okay, and then finally we ended up with distance between 2 points, x1, y1, x2, y2, and that's just this deal here, big square root over these 2 terms, and that will help you calculate the distance between any 2 points. Now let's take a look at some of the terms we discussed along the way here. So starting off, we spent some time with parallel and perpendicular lines, and basically I'm just giving you the notation here. We'll go through it. So line 1 is parallel to line 2 if the slope, that's the lowercase m, the slope of 1 is equal to the slope of 2. So basically parallel lines have the same gradient, okay? Now perpendicular lines, we write that L1 is perpendicular to L2 if the slope of 1 times the slope of 2 equals -1. So that's your test to make sure that your slopes are related by the negative reciprocal, which of course is what I put here. Gradients are negative reciprocals. So you can always test it. If you have those 2 slopes, multiply them together, you should get -1. Okay. Then we moved on to this concept called perpendicular bisector, which was essential for creating our Voronoi diagrams. So for a segment, we bisect segments, not lines. It must go through the midpoint of the segment, and it must have a gradient that is a negative reciprocal of the segment's gradient. So I drew a diagram of that. Here's segment AB with midpoint M. Here's my perpendicular bisector. It's perpendicular to AB, and it goes through the midpoint. And we did a bunch of work here for being able to create equations of perpendicular bisectors, being able to find midpoints and all of that. And that all came together in the Voronoi diagram. The last thing we covered is the Voronoi diagrams. So let's take a look at some of the terminology there. We have vertices, boundaries, cells, and sites. So there's a very simple Voronoi diagram, no numbers on it, just sketched really fast. And basically what's going on here is everything in this region is closer to A than to B or C. So this could be a hospital, a fire station, something like that. And then everything in this region is closer to B than A and C, and everything here is closer to C than A and B. So this can be a practical diagram that could be used in a city to figure out which hospital to go to or which fire department to send, things like that. So vertices, those are where boundaries meet. That would be that point there. There's 1 in this diagram. The boundaries are the dividing lines between the regions, which are called cells. So that's this keyword. This whole area is the cell that's around A, cell around B, cell around C. And then finally the sites are the actual sites. So this would be like hospital A, hospital B, or hospital C. Okay? So the overall process for creating one of these diagrams is we construct the perpendicular bisectors of the segments connecting the sites. And then once we've got those bisectors in there, we do a little critical thinking to figure out which lines that we erase so that we can just leave the relevant lines for our Voronoi diagram. Now that you've watched the video, take a moment to write down any remaining questions so you can ask them at our next class. Also remember that you can come back to this video again to refresh your memory. If you like the video, please click like or subscribe.